We've been talking about functions and the properties of functions. We talked last time about whether or not a function is odd or even. Today, we want to talk about increasing, decreasing, and constant functions. So we're going to start with a little bit of a restriction. We're going to say that A is less than B. So if you think about a number line, if A is less than B, A is always going to be to the left of B. Let's start with an increasing function. We say that a function is increasing over an open interval A to B. So let's see what that looks like before we give our definition. We've got A on the left, B on the right, and it doesn't have to be on different sides of the y-axis. It could be on the same side. We say that a function is increasing if the f of A is less than the f of B. Remember what that means. It means if the y value at A, so if this y value for A is less than the y value for B. When we look at it, we can see that it's rising to the right. So as you look at it from left to right, it's rising as you look to the right. Now I want to say something about this open interval here. Remember that the round brackets are open brackets. We could also describe this as a closed interval. It doesn't have to be open. I think in Pearson, in my lab, it doesn't matter whether you use an open or a closed interval. Just be consistent. Are you using open brackets or closed brackets? So if that's an increasing function, what do you think a decreasing function looks like? Again, we're going to say that A is less than B. Decreasing says that the f of A is greater than the f of B. The y value at A is greater than the y value at B. And if we're reading it, again, from left to right, we see that it's going down to the right. What about a constant function? A is less than B. Here's our constant function. The f of A equals the f of B. A constant function is simply a horizontal piece. So let's look at this graph. Is this the graph of a function? Yes, it is. No matter where I draw a vertical line, remember we're using that vertical line test, it intersects the graph of the function exactly once. So we know we have the graph of a function here. And we're going to look at open intervals because that's what's asked for here. But remember, you can use closed intervals if it doesn't ask for anything specific. We're looking for the open intervals from A to B. Let's go back here. From A to B. That's asking where on the x-axis. Where on the x-axis from A to B. So when it asks us to find the open intervals from A to B where the function is increasing, let's look at those pieces where the graph is going up to the right. We see it's going up here, and then it continues to go up. That piece of the graph is increasing. What is that from A to B? Remember, we're looking on the x-axis. We see that it starts at -3 all the way to 0 on the x-axis. That's the interval where the function is increasing. Where is the function decreasing? Well, I can see right here, it's going down to the right. And here, it's going down to the right. Those are the pieces where it's decreasing. What is that on the x-axis? Here, from -4 to 3, and here, from 2 to 4. Sorry, that was -4 to -3. And we use a comma here. And also from 2 to 4. We only have one piece of the graph left. We can see that it's horizontal or constant. Where is that on the x-axis? It is constant from 0 to 2. Watch that again and then go do the practice questions in the next video lesson.